This is our last lecture, heuristics. In this lecture, we use different examples to show you how heuristics actually working for the large-scale mathematical programming models. We actually do not have this chapter in the textbook, so we use a supplement material. You should first download the materials from Blackboard. So the agenda of today, so we start from the learning objectives, then let's see what is heuristics. Then we talk about the knapsack problems, traveling salesman problem, and capacitated vehicle routine problem. It's actually something missing here. I actually also add a next question. So actually, it's a workload smoothing problem. So all these problems actually are difficult to be solved to optimal, especially when the problem is large. So we pursue heuristics. So learning objectives. Be able to understand the integer linear programs are difficult to solve. So we actually have done different types of integer linear programming models. Normally this type of problem are NP hard. So it takes a long time to solve. So in reality, quite often, in order to solve the problem within the limited time and the capacity, we may use a heuristics method to find a good solution, so not necessarily optimal, and be able to use and develop simple heuristics. So here in this course, we have only one lecture to talk about heuristics. So don't worry, we not really pursue the large difficult problems. We use a small examples to show how to implement heuristics. So heuristics was initially developed because even though we can solve a lot of problems by linear programming, integer programming, even quadratic programming, mathematical method, but the computational complexity actually is always an issue. So this directly related to the time to solve a problem. So far, we have done a lot of cases or examples in Excel solver, and you can quickly find the solution, but it's not always true. So it's often in reality, the computational time or complexity increases significantly when you increase the problem size. So here we have this knapsack problem as an example. So first, to solving combinatorial optimization problem is hard. It's very difficult. So for example, even the 0-1 knapsack problem in Excel, you can see a very simple problem. So you have n items, you have one bag. You're allowed to take as many as items into the bag, but you are not allowed to actually overload. So now the question is how much time you can actually solve this problem. So the complexity for a 0-1 knapsack problem with n items actually have a complexity of 2 power of n. So that also means you need to check 2 power of n different possibilities. If this is the computation time you need, of course, the larger n is, the longer time you need to solve that. So, for example, here when you have 2 items, then you have 4 solutions to check. You have 8 items, then you have 256 possibilities. And when you have 32 items, then you can see the potential solution, number of solutions is up to huge number. When you have 300 items, basically, it's impossible to solve. So for such large problems, so we need an alternative method to solve that. For example, you work for maintenance business, so you serve for the equipment located all over the region. You may need to go and visit the set the field and then decide how to fix the items or fix the problems with machines, equipment, or whatsoever problems. Then normally you drive a car, but one machine may have millions of components or items. You don't know what is failed, so you need to take the component with you in the car, but which item should you bring? So that's probably is a heuristic decision to make. This actually happens even in our daily life. The electrician came to visit and found they couldn't fix our problems. They needed to actually drive the car back home to find the right component and come back again. Okay, may they even need to come another day. So that's actually it's a serious business problem as well. Of course, it's okay if you can find a good solution, but how to find a good solution actually is not an easy task. So here we first need to know what is heuristic. So heuristic is a rule of thumb. So it's just a simple solution you initiated. So this actually should get the decision making. So should be at least feasible, lead to the right conclusion or result. So should be good. So find good solutions approximating an optimal solution to the difficult problems. It doesn't mean you just find a feasible solution. So heuristic as a scientific method has been developed dramatically in past 20 years. So they actually have a serious theoretical method to go through to check if the solution should be accepted or not. So I'll do it faster than exact method. This actually normally is one of the actual objective. We want to solve the problem efficiently. For example, the supermarket would like to quickly find a route, delivery route for every day's customer goods delivery, but the customer actually places orders in time, so over time. So how can you actually quickly satisfy the customer within a short time window? So of course efficiency is more important in optimality. So heuristics are mainly used for 2 reasons. Sometimes we cannot hope to solve a problem to optimality. The problem is too difficult to be solved to optimality within a reasonable time, so we settle for heuristics. Sometimes just because heuristics are simpler and more readily understood than exact optimization method. So the first reason normally is the commonly accepted reason. Heuristics do not guarantee optimal solutions. This actually should always be remembered. If you find a solution optimal normally is the best, so cannot be better. The heuristics may be improved up to optimal solution, but normally no guarantee. So heuristics can be divided into two categories. One is called construction heuristics. One is called improvement heuristics. So that's easy to understand. The construction heuristics means you start from scratch and just build an initial feasible solution. And then improvement heuristics is based on the initial feasible solution, and you start to search around and see if you can further improve the initial solution. And then you find a new benchmark and continue to improvement. Normally, improvement heuristics is continuous improve process. Improvements process. So here there are many different methods. So you just know the names, not necessary to know the details. We use examples to show you how it is. So we use a case to show you the heuristics methods, the process of heuristics method. So here we have the example for the project scheduling problem with resource constraints. So in the textbook, this type of problem also named as workload smoothing. So if you go through the textbook, you can see also more details about how this method is working. So I use this case to show you the entire process. So let's say I have a project. So you should be familiar with this type of table. So we have activity. So you can also see this activity name. It's not a best way. We use actually numbers to show. So you can also name that as activity 1, activity 2, and so on. So the predecessors also given for each activity, and the durations also estimated, and we also have the third type of information which we have not experienced before. That's called the resource use. So this actually is a normally existing constraint for your problem. For example, in order to finish the activity 2 within 6 days, so 6 days is the duration, and the resource use 7 means you take 6 days and each day you need 7 units resources. For example, 7 equipments, 7 computers, or 7 work laborers. So that means 7. For activity 4, for example, the duration is 3, and you need probably 5 persons to work 3 days to complete this task. So the rest is the same. You know the resource consumptions and you know the durations if you get the sufficient resources. So now in this question, I have extra information is the total resource availability. It's a single resource 10 units. So you actually have a capacity constraint for this problem. Every day you can use maximum 10 units resource. So this problem can be solved as a linear programming model. So we actually put the formulation here. You can see we want to minimize the total completion time. So this is a SN, so it's a finish time of your project. And then it's constrained by the first constraint is a precedence relationship or predecessors. Or we call it precedence constraints. And the second constraint is a resource constraint. So because it's actually a network problem, and with a resource constraint, it's normally very difficult to be solved. So we do not actually suggest you to solve this problem to optimality. So we provide you a heuristics to solve this problem. As you can see here, we see in order to solve this problem, you have exact procedure. So that means optimal method. So this normally can solve the small problems, but for that large problems, it's rather challenge. And then you can pursue the heuristics scheduling procedures. So this actually just aim at find a feasible good solution. So not necessarily optimal, but we focus on a reasonable time. So the concrete heuristics algorithms actually are proposed in the textbook. I also proposed another better constructive heuristics. So basically, we have two types of heuristics introduced in this book, in this lecture. In order to give more details, I do the screencast for these two methods. So you just try to download the workbook and then go online and try to watch the video and see how this heuristics method are working. So here I just use a couple of minutes to briefly talk about this constructive heuristics. So this actually is a priority rule based heuristic. So the idea is we choose the activities to schedule at the higher priority if the duration is short. And of course, this priority rule is not fixed. So for example, here in the case, I'm going to use the shortest duration with a higher priority. Of course, you can also do others. So you can schedule the activity which is have many successors, because they will affect the future progress, or you can also do other priority rules. And also we need a schedule generation game. So that means when you generate new activities into your solution, then you can decide that you can generate multiple activities at one time. You can also generate one by one. So here, normally, the most commonly see scheme is a parallel scheme or sequential scheme. You see that in the screencast. So the details about the examples, please download and study the Excel workbook and also watch the screencast. For this specific example I use, you can see I got actually the heuristic solutions. So this is actually a schedule, a project schedule. Just write it as a resource loading chart. So this type of chart called resource loading chart. So the these two charts shows the different schemes. So first remember is a sequential scheme. Second one is parallel scheme. So, for example, we see the first solution. So this is a heuristic solution. And presented as a resource loading chart. In this chart, you can see at the time 0, you start to schedule activity 3 and 4, and then in the different times, you start to load different activities. And now you always consider the resource constraint over time, so the resource constraint actually abates, so not deviated. So that's basically the solution we would like to have for this problem. If you follow the heuristics procedures, you will understand how to get this solution. I do not do that in this video, so try to check the screencast. So I mentioned this case because I would like to continue the discussion about the heuristic algorithms. So apart from find the solutions, that's also very important. You should be able to evaluate the heuristic solution. In this project scheduling case, we try to actually minimize the completion time or the project duration. So it's a minimization problem. So then if you know the lower bounds, so of course for the heuristic solution, the best lower bounds is optimal. So if you can evaluate, okay, my heuristic solution is close to optimal, then that's a good heuristic solution. But sometimes we do heuristics because we cannot find heuristics. We cannot find optimal solutions. So that's why we need actually to find a lower bound. So the purpose of lower bound calculations is to validate the quality of our project schedules obtained by software tools or simple methods, such as priority rule-based scheduling techniques, so the heuristics. So in our specific case, 3 lower bounds can be calculated. Given the time and the course focus, so I actually only mentioned the first 2, critical path-based lower bound and the resource-based lower bound. Critical sequence lower bound actually is not mentioned here, but it's also not difficult to do that. If you're interested, you can check the literatures. So let's see the critical path-based lower bound. So this actually based on the name, then you can probably understand. If you know the critical path, so we basically ignore the resource constraint. So you just implement our critical path method. It's a wrong writing. So it's a critical path method. So ignore the resource constraints. Then the solution will be the length of critical path. So this solution actually is even shorter than the optimal solution. So this lower bound actually is lower than optimal solution. So if your heuristic solution is close to this lower bound, at least shows your solution is also close to optimal, because optimal is between the critical path lower bound and your heuristic solution. So next, second lower bound we can use is a resource-based lower bound. So in this case, we ignore the precedence relations. So it's just relax the constraint for for this problem. So the precedence relations is not considered. So we calculate the average time you need if you just sum up all the resource usage for all the activities and divided by the resource capacity. Then you get a average actually time you need. This actually also less than the or equals to the optimal. So this can be considered as a lower bound. From these two lower bounds, we can see the lower bounds often report infeasible results. They may lead to an unrealistic optimistic schedule objective, and heuristic solutions we proposed provide a feasible schedule, but still may not be optimal. So the gap between the lower bound and the heuristic schedule gives an indication about the room to improve for your heuristic solution. That's also we say we can use a lower bound to assess the quality of your heuristic schedule. So here in this graph, this figure, I'll try to show you. Here you can see our lower bounds actually all infeasible. So this actually even smaller than optimal solution. So here the optimal solution located here, your lower bound even smaller than optimal solution. So here the heuristics normally considered as a feasible solution. Heuristic solution normally is feasible, but probably not optimal, so should be greater or equals to optimal. So this relationship shows how you can improve. So if this optimal solution is difficult to obtain, then here you have the gap to improve. Of course, it's possible to improve a heuristic until the lower bound, but the idea is to move closer to the lower bound. In our project examples, project scheduling examples, I actually have the data here. So optimal solution actually is 25 days. And the lower bound, we have two critical paths based lower bound is 17. And resource based lower bound is 19. We actually have a next one, the critical chain based lower bound, which is 21, but these are infeasible. Optimal is 25. I actually also have a heuristic solution, also 25. So this is from the sequential scheme, and also have a 27 from parallel solution. So you can see the sequential heuristic performs actually best, because it's actually we don't know 25 is optimal. Then you can see it's actually close to 21, so it's good enough to accept that. And also we cannot find a way to continue to improve that. So that's also why validated good solution. So in this lecture, actually you do not need to do all the validation or evaluation of the heuristic solutions. The purpose I mentioned this is to tell you when you develop a heuristic solution, it's necessary you evaluate the quality of your heuristics. Apart from the project scheduling example, we also use the other examples to show you the different heuristics method. For the knapsack problem, we do a greedy heuristics. This Excel workbook is available, and I will show you how to get all these different types of heuristics in the screencast. We also using the traveling salesman problem to show you how to do the sequencing. So in the textbook, actually talk about a sequencing method or heuristics. This method actually is used for our traveling salesman problem. So you can read the textbook and try the example. Last example is capacitated vehicle routine example. This example based on another reading material uploaded in the Blackboard. So it's Clark and White algorithms, written by Jens Lusko. So you need to read the material. I also do the Excel workbook screencast to tell how this method is working. The method to solve the capacitated vehicle routine problem actually is based on the Clark-Wright savings algorithm. So this algorithm's core idea is you pick up any two locations in a map, and then if you could save costs by connect these 2 points together, we should be able to calculate the cost savings. Because if you try to drive the items from node I to node O and back, and from node O to node G and come back, then you actually go 2 routes. And the idea in this algorithm, heuristic algorithm, is if you start from point 0 and go to point I, and then continue drive to node G and then go back to the depot, you actually save some routes. So for example, the routes from I to 0, from J to 0 actually. So if you take these routes and these routes actually are saved, and then you continue to drive from I to G, so of course you add one more route. So then the cost saving for this different routes is actually from I to 0, from I to 0, from 0 to G, and then you add extra route CIG. So that's how you calculate cost savings. And after you have this all calculations between any 2 nodes in your map, then you actually can decide which points should be connected. So this actually can continue to be extended to even longer route. So now you have I0. So initially you have 0, I0, then plus 0, G, back to 0. And in the second situation, you actually have 0 to I to G, back to 0. And you can also extend this route to more points. For example, you can do 0 to I to G to K to 0. You actually can save even more because you save the routes from 0 to K and from G to 0. So that's the idea. You can continue. Here, how long you can go depends on the capacity of the vehicle. So if the customer demands in the different positions, different locations, as smaller than your capacity, you can continue to go on these routes. So of course, if you cannot carry all the demands, then you have to end your routes. So that's a basic idea about this. So this problem also used in your tutorial exercise. So prepare that before you go to tutorial. Actually, in this slides, I missed one thing. That's actually called macros. So this actually also means VBA code, or if you name that computer programming in Excel. So this actually is not required in the exam. So it's definitely beyond the scope of the exam. It's only for your personal interests. If you already know how to coding or how to write a VBA code in Excel, then you can check our examples. I just wipe it. So you can check all the examples I have done. Examples with macro. So for the two of the previous examples, apart from the manual procedure for your heuristic algorithms, we also provide you the heuristics with heuristic with macro. So basically, what I did is to program the heuristic algorithms or the searching process in the VBA code, and then you can repeatedly run the code for different setting of the numbers. And when your problem becomes larger, you can also reuse the code. So of course, it's only for your interests. So if you want to continue to study in these areas, there's also you have the chance to learn the coding VBA programming in our master program. So it's no hurry. I just want to show you it's possible to handle the more complicated problem in Excel. So that's about the heuristics lecture. This is also the last lecture I gave. I would like to say thank you for the semester. This semester has been really difficult, different. I know it's very challenging to work alone at home. So you have done a good job. So now we are going to offer you a question and answer session before the exam after this last lecture. So if you have any question, you can come to join our Zoom meeting. So the last thing I would like to see is a best luck with the exam.